Okay, recording. Are you there? Hello. Okay, good. Okay, so today we are at your chapter 4 or tutorial 4. We look at these 4 topics: your Bernoullis Trunk, binomial distribution, normal distribution, and this thing called central limits theorem. Central limits theorem, you'll kind of look at it in multiple chapters, but we'll talk about the first thing today. Very importantly, you have to know your binomial distribution and, even more important, normal distribution. Okay, so let's get started. Number 1, let's look at your Bernoullis Trunk. Okay, so what is a Bernoullis Trunk, or what is a Bernoullis experiment? How do you define that? Anyone? Hello? What is a Bernoullis experiment or Bernoullis Trunk? Anyone want to say something? I'm not muted, right? Hey, how about Keith? Want to say something?
Bernoullis Trunk is is an experiment with exactly 2 possible outcomes. It's either a success or a failure.
Correct. So it's basically an experiment, okay, with 2 outcomes. Okay. So the 2 outcomes can be, either A or B, can be success, failure, it doesn't matter. Now, must the probability be the same for success or failure?
No.
No, okay. So the probability just try my finger. Okay. The probability of success need not be the same as the probability of failure. Okay. So for example, your 4 choice MCQ questions. Okay. The probability of getting correct, if you answer by random, is 25%, but the probability of getting wrong is then 1 minus the probability of getting correct, which is then 75%. Okay, so that itself covers Bernoullis Trunk, and very important, remember this part, it need not be the same. Okay, so let's save this. Hello. Okay, save as 1. Okay, so now we have covered our Bernoullis Trunk. So we have also talked about normal distribution in the lab itself. Binomial distribution. And binomial distribution is for us to find the probability of exactly an event happening. Okay. So very important here is it is actually exactly an event. So for example, you can say that you have a 20 MCQ test. Okay. What is the probability of getting, let's say, 11 marks or 11 correct? Okay. That you can use binomial distribution. Okay, and importantly is this. There are a few important points. Number 1 is each question here, each MCQ is actually a Bernoullis Trunk. The second thing is that the questions or the trials are independent. Okay, meaning to say that, example like question 5 does not affect question 6. Okay, so the trials must be independent. Very important. The third is that the probability of success for each trial is the same. Okay, which also means that the probability of failure for each trial is the same. So that you can use your binomial distribution. Okay, we have done that in the Tuesday as well. Yes, save. All right. Now with that, can anybody give me the whole equation for how to calculate binomial distribution? If so, let me just erase. Okay. So we say that R is the number of success, N is the number of trials, P is probability of success, and Q is the probability of failure, which also means that this is actually 1 minus P. Okay. So I want to find the probability of getting a specific answer. What is the whole equation? Can anybody tell me? Let's see who else will want to speak something. Gerard?
Yeah.
Okay. What's the equation? Yeah, what's the equation? Having a tutorial.
Wait. It's the binomial distribution equation, right?
Yes.
Okay, N is the number of trials, R is the
Right.
rate
Here
of
we have,
success,
yes. Then multiply by?
multiply by PR, P being the probability of success,
To the power of R, correct?
the power of R.
Multiply
Then
by?
multiply by Q to the power of N minus R.
Correct. Okay. So this equation you have to remember well. Although I think it's also in your notes as well. Let me see. How do I find it? How do I get to here? Okay, so okay, it is also in your formula sheet. In fact, yeah, it's also in the formula sheet here. Okay, so you have to know what how to use a formula sheet. Okay. All right. So in this case, if we already said in our tutorial, lecture, let's say for example, we have, okay, for example, let's say you have 10 MCQ questions. Okay, and each one will have 4 answers, 4 choices. and you want to see what is the probability of getting 5 marks. So in this case, you just work it out. It's 5. Okay, so you have 10, 5 multiplied by the probability of success is 0.25. 5 times 0.75. 5 here. So you just work it out. You will get it. Okay. So that is your binomial distribution. Okay. Now the trick here is to read the question carefully. Okay. For example, we always use the term at least how many. Okay. At least how many? At least 6, or at most how many? Okay. Or all, or none. So you have to read the question properly. So we will come to that in the question 2 and question 3. Okay. Now the next part that some of you, how many of you do not know how to use log or ln? Log or ln?
Sure, sorry, can I ask? So when do you use the standard table again?
When we come to normal distribution, this has no table. You actually make the table yourself.
Okay, got you.
Okay. The table is not for normal distribution. Okay. So log and ln, make sure you know how to use it properly. Okay. So that itself is binomial distribution. Now for normal distribution is quite different. For normal distribution, it works this way. Normal distribution actually is a curve in itself. So let's just say that if things are normally distributed, you have your x-axis. Okay. Then in this case, the y-axis is actually your frequency. Okay. For example, we say that the mean, let's say the mean is 100. The standard deviation is 15. Okay. So what you have here is the mean is 100. Okay. So 1 standard deviation, 2 standard deviation, 3, 1, 2, 3. So here will be 115, 130, 145. Okay. Here will be 85, 70, 55. Okay, so you have a normal distribution. Now what happens is we want to calculate area under a curve for normal distribution. Area under a curve for normal distribution, assuming that this is your frequency, and then you have a function. I keep repeating this. To find the area under a curve, which is then the probability, you integrate the function, the curve itself. Okay, this you learn in secondary school. For those who have done A Maths, for you who have not done A Maths, just know that there's this concept. But rather than you have so many different tables, because all of your data, the mean can be different. The mean can be different. The standard deviation can be different. Rather than you have so many different types of table, we just standardize it into one table. Standardize it into this thing known as a Z-score table. Z-score table, okay, will have these properties. Number one is the mean is always 0. The standard deviation is always 1. Okay, so which means that here it's actually 0, 1 standard deviation, 2 standard deviation, 3 standard deviation, minus 1 standard deviation, minus 2 standard deviation, minus 3 standard deviation. Okay, so every time before you do anything, you have to do one important step. You have to convert your X value, the actual data, so this is the actual data, into the respective Z score, Z score. And how do you do that? That means how do you convert between these two axes? Okay. The equation is this. Z score equals to the X value minus of the mean divided by the standard deviation. Okay, so how does this even work? How do I get from X equals to 115 to Z equals to 1? That means how do I convert between these two? Okay, so my Z is actually 115, which is my X value, minus of the mean, which is 100, divide by the standard deviation, which is 15. So here I end up with 15 divided by 15 equals to 1. So that is why it is 1. Okay, and two very important properties. Number one is your normal distribution is symmetrical. Okay, that means these two sides are the same, symmetrical. The second is the normal distribution, the line itself, never touch the horizontal axis. Never touch horizontal axis. It's asymptotic. Because it never touched the horizontal axis, essentially, you can never get the probability equals to 0 or the probability equals to 1. Because the probability equals to 0 means that the X value is actually minus infinity. The probability of 1 means the X value is actually, what they do? X value is actually, something is wrong here. The X value is actually infinity. All right. Rather than confusing you, make sure that you are able to convert between the Z value and the X value. Okay, this thing. So this is actually quite critical. Okay. And how does the normal distribution table help you? So let's look at the normal distribution by itself. Okay. Now let's look at a normal distribution, which is on your appendix 2. You realize that it only starts from 0 because the Z only starts from 0. How you read this table is this. The rows give you the integer plus the first decimal place. Then this gives you the second decimal place, or the columns gives you the second decimal place. Okay. And what it shows is the highlighted region, which means that the highlighted region at 0, which is essentially the whole thing here, is exactly 50%. So this is 0.00. Okay. On the other hand, what happened is, can I undo this. How to undo this? Maybe let's erase this. Yep. Okay, this is the stupid way of erasing. Okay, delete. Okay, so let's say, what do this mean? This number mean? Okay. It means that this is 0. Okay. Here we have, at this point, we have 0.09. The area so how do you find the area, let's say, of this, the opposite side? For example, this is 2.1. What is the area here? Minus 2.1. So since minus 2.1 is actually the same as the area for 2.1, 2.1 and beyond. So you just go to 2.1, 2.10, which is this answer. Okay, 0.0179. This is 0.0179, so it's 0.0179. Okay, so do you know how to read the table now? The normal distribution table is essentially a table to convert the probability and the z-axis. Okay. So for example, we want to do something differently. Let us just say that we want this now. Okay, the normal distribution. Okay, and I want to have here. Okay, the shaded area is, let's say, 0.07. Okay, I want to find out what is this point on the z-axis. How do I find out? What I will do is I will go to the table, look for 0.07 in here. So 0.07, so you take 0.07, 0.06. So this is the closest. So you take the next one, which is here, spot. Okay. So the answer here will be, make sure you don't have a parallax error, 1.48. Okay. Which means that at this point it is about 1.48. Understand? Hello, are you there?
Sure.
What?
If we choose the other number, and like example in exam, and then we get just like a slightly different answer, 1.47, does it matter?
Sometimes, not all the
Like
time.
we choose 0.0708 instead of the 691.
Actually, it does matter sometimes. Okay, because look at the question. If the question says that you want at most 7%. So this is more than 7% already, so you cannot use it. Got what I'm trying to say? So we have one question inside a tutorial that says that if you only, let's see, what is the tutorial? Yeah, question number 6C. For example, the manufacturer doesn't want to exchange for more than 10% on tracker. That means your failure rate should not be more than 10%. So you cannot have more than 10% failure rate. Got what I'm trying to say?
Yep, understood.
Yeah. So if you take this, right, for example, 10% failure rate, you should actually take this number, which is 1.29. If you take 1.28, that means your failure rate will be 10.03%. It may not seem like a lot, but if you are manufacturing, thousands of equipment, then that 0.03 may hurt your profits. That's what I'm trying to say. Okay, so let's just say this can be delete. No, okay, I cannot delete the page. Okay. What am I doing? Okay. Anyway. Okay. Right. So this is actually very important. If you do not know how to actually look at it, please draw out. Okay. I will say that always draw this diagram and shade it yourself. Okay. So for example, what happens if you need to find out this? Okay. Let's say you want to find out this area instead. Okay. Let's say you want to find out this area, and here is 1.48. If you want to find out this area, the table doesn't give you this. What the table gives you is this blue shaded region, which then the table tells you that it is 0.07. Okay. So the probability of Z that is less than or equals to 1.48 is actually the total area minus the blue shaded area, which is 0.07. That gives you 0.93. So this is a blue shaded area. All right. So you have to see where you are. Similarly, we can do the opposite. This is what we have done just now. If for example, I want to find out this area, okay, and here is 1.48 minus 1.5 because it's 0. The table, normal distribution table, doesn't give me this. Normal distribution gives me the opposite because it is, remember, this is symmetrical. So normal distribution table gives me this instead and tells me that at this point, at 1.48, this is 0.07. Therefore, this portion here is also 0.07. All right. Okay. All right. So let's look at the next one. For example, if I were to do this, here is 0. This is the z-axis. I want to find the area in the middle. Okay, and this is, let's say, minus 0.5 to 0.2. I want to find out what is the area of this shaded region, this blue shaded region. Okay. How do I find out? So fundamentally, my question is, what is the probability of the blue shaded region, which is minus 0.5? Oops, let me just rewrite it clearly. Minus 0.5, 0.2. Okay. So what should you do? You can think about it at 3 different ways. Number one is, what is the probability of at 0.2? What is the probability of this orange shaded area? correct? So now, if you go to the table, at 0.2, what do you have? Can I actually erase all the marks? Yes, I can. Delete. Okay, good. So at 0.2, I will have here 0.4207. It tells me this is 0.4207. Okay, so this is what I have. Now, then I can do the repeat. If I take the total area, which is 1, minus the probability that Z is more than or equals to 0.2, I will end up with the opposite side. So I will end up with this portion. Okay. The next step is to do the reverse. Okay. I want to get what is the probability of 0.5. So I want to get, let me just change to green. I want to get the probability here. Okay. But this doesn't allow me to, the table doesn't allow me to do that. What I can do is do the reverse. I can get the probability on this side. Okay. Which is then here is 0.5. Okay, because these are symmetrical. So let me go to the table. At 0.5, I have 0.3085. So this is 0.3085. So is this area 0.3085. So I minus off the probability of Z that is more than or equals to 0.5. Okay. So I will get it instead, basically here, this is 0.3085. And then what I end up with is this part, which is 0.4207. So it becomes 1 minus 0.4207 minus 0.3085. So this is this region, and the green is this region. So my real answer is, oops. Can somebody help me take a calculator and calculate what is 1 minus 0.4207 minus 0.03085? Someone calculator, quick.
0.2708.
2708, correct. Okay. Anyway, I assume that your calculation is correct. I don't have a calculator. So this is actually the blue region. So this region here is 0.2708. Okay. So you do step by step. If you do not know, draw step by step and know what you're doing. All right. So this is actually quite important. Step by step. Okay. Now, then we actually have one more problem. Okay. One more question, which is what this central limits theorem. Okay. Can anybody explain what is this central limits theorem? Yeah. Is it already covered in your lecture? Can somebody tell me, is it covered in your lecture for central limits theorem? Does it mention anything that before? Yes, no? Hello? Is it mentioned in the lecture? Okay, it doesn't matter. But what central limits theorem says that, okay, essentially, regardless of the original underlying distribution, okay, if the sample is large enough, the average or the mean of the sample okay is equals to the mean, and the standard deviation of the means is equals to the mean standard deviation divided by square root of n. Remember, this standard deviation of the mean is actually what we know as the standard error. So this is a very kind of useful and yet very abstract theorem. It means that it doesn't matter the population, what kind of distribution the population is. The distribution could be all over the place. The distribution could be normally distributed. The distribution could be skewed. It doesn't matter. But if I get enough samples, so I have sample 1, sample 2, sample 3, all the way to sample n. The average of the samples is actually approximately the average of any one sample. While here, because a sample, right, I can calculate the standard deviation of all these sample means, correct? I can calculate the standard deviation of all the sample means because each one will give me one sample mean and calculate the standard deviation on the sample means. We actually covered this in the first lecture, I think. This is what we call as your standard error. And it is approximated by any one standard deviation divided by the sample size of the sample. This is the size of a sample. Okay. And it tells me that the averages, which is the mean 1, mean 2, mean 3, all the way to mean x, these data will be normally distributed. Okay, so this is actually very important. So now, rather than giving you so much so abstract, let's look at how we can use this. Let me just give you a question. Okay, I'll write the question here. So, question, let's say 1. Okay, let's say that if I have I want to measure the height of students. Okay, so I collect a sample of 20 students, or rather a sample of, let's make it bigger, sample of 100 students. Okay, and I found that the average, yeah, my handwriting is getting terrible. Height is, let's say, 170 cm. Okay. And the standard deviation is, let's say, 10 cm. Okay, now, so this is the thing that we want. But my question now becomes, one, what is the probability of finding a student with height more than 185 cm? What's the probability? So how do we calculate this? So you want to find out the probability, the height more than or equals to 185. Okay. So the first step is you convert the height into a z-score. So you have to be z more than something. Remember, the equation is actually your x value minus of the mean divided by the standard deviation, which is then here z, here will be 185 minus of 170 divided by 10. So in this case, z is more than, so 15 divided by 10 will be 1.5. Correct. Okay. So then you go to the table, find out where is your 1.5. Oops. Okay. 1.5 is here. 0.0668. So the answer is 0.0668. So then you write down the probability of finding a student with height more than 185 cm is 6.68%. All right. So this you can do. Any problem up to this point? Okay. So what I'm going to show you is another way of asking the question. The second one is, let's say, for example, I took a sample, another sample of, let's say, 25 students. What is the probability that the average height of these 25 students is more than or equals to 175 cm? So you see the difference here? Here I'm finding the probability of one student. Now I'm finding the probability of a sample of students. Okay. So what I would write here is the probability that the average height is more than 175 cm. I have to convert it into the z-score as well. Okay, I convert into a z-score, but this time I'm using it differently. I still have my x, my average height, minus of this height, which is 170, divide by, now the standard deviation is different. I have to use the standard error. So how do I use the standard error? Remember standard deviation? Standard error is actually standard deviation divided by square root of n. So in this case will be, here will be minus the mu itself divided by this, which is then 175 minus 170 divided by the standard deviation here is 10 over square root of 25. Okay. Then you have 5 divided by, what is 10 over square root of 25? Two, right? So this will be 5 divided by 2. 2 is actually 2.5. So you go back to your table to find out what is 2.5. 2.5 is here, 0.062. So here is 0.0062. Okay, so the probability that the average height of 25 students that is more than 175 cm is 0.62%. Remember, we are talking about one student here. We are talking about a sample of students, a group of students. What is average height? What is the probability of the average height versus what is the probability of a student having the height of something? Okay, so this is a very important thing. Now, if you want to do statistics well, you have to learn normal distribution very well. Okay, once you know how normal distribution works, everything in statistics is manageable. Normal distribution is the first checkpoint of statistics. Okay, if you do not know how to do that, then everything else from this chapter onwards, you are going to get confused. Okay, which means that if you do not know normal distribution well today, next week when we do your hypothesis testing, everything you'll be confused until the end of the semester. Okay, so please, this week is a very important week. Get your normal distribution well.
Can you help me draw the graph of this one?
Okay, see, hold on. You mean the distribution curve?
Yeah, the distribution curve for the second part, because I cannot visualize.
Okay, so for the second part, it will look something like this. Okay, let's see if I can do it. Now, the first thing is, for part 1, this is not a problem. Okay, you have your height, so it's 170. Standard deviation is 10, so 180, 190, and so on. Okay, 160, 150, 140. Okay, so it's fine. This part you're okay, right? So this is the mean. Okay, then when you convert into the z-score, this will be 0, 1, 2 standard deviation, minus 1, minus 2, minus 3 standard deviation. Okay. The second one will look something like this. Because you are no longer taking the height, but the average of the height. The average of the height is still the same. Here is 170. But your standard deviation is different already. Okay. Here, the average is 170. Standard deviation is 10. When you convert it to this step, the height, the average remains the same. But the standard deviation, which is here called the standard error, is actually, here you need the sample size. So the sample size, just now we have 25. It's actually 10 divided by square root of 25, which is then 2 centimeter. So here becomes the average height is 172, 174, 176. So it's minus, 168, 166, 164. And because of that, the z-score remains the same. This is 1, 2, 3. Okay, so this is the z-score. So just now, what is my question? For the first one is 185, right? So 185, I am looking at this area here. So can somebody repeat what's the answer just now? What's the area here?
Uh, 0.0668.
0.668. Okay, correct. But on the other hand, I can't remember what's my question. So I'm asking 180, right? Or 185.
185.
Okay, so more than 185. Is it 185 just now? Or 180?
Wait, you're talking about part 2, right?
Part 2, yeah.
Oh, sorry. Is more than or equals to 175.
Okay, more than equals 175 cm. Okay. So here, if you look at 175, 175 is actually here. Okay. And then this, oops. This is actually a smaller number. So just now, can somebody help me repeat what is the number here? The shaded area.
0.0062.
0.0062. Right. So you see a difference? Because the unit are different. This is height, this is average height.
Oh, okay.
So that's the important part. The question is just one word, a few words difference only. So please do not misread the questions. Okay, there are students who misread the question and then get the whole question wrong. All right. Okay, so with that, where am I? Hello. Okay, let us do your tutorial questions. Okay, just save it. Yeah, correct. Save it. Ready? Let's do your tutorial questions. So let's get the question 1 first. Okay. Question 1. The answer is true, false, false, true, true. Okay. The only problem that you will have most likely is the second one. If we randomly select 5 students to form a class committee, the number of male students selected follows a binomial distribution. It is false. Because when you select the first student, the rest of the student probability of male students change. So remember, binomial distribution, every time when you do something, the probability cannot change. Let's say in a class of 25 students and there are, let's say only 10 males. So before you select the first male, you have 10 out of 25. You select the first male, technically the rest becomes 9 out of 24. So the probability changes. That's why it doesn't follow a binomial distribution. Okay. Question C is also something that you get a bit confused. Binomial distribution is a discrete distribution, whereas normal distribution is a continuous distribution. Because they are so different, we shall never use a normal distribution to approximate a binomial distribution. That is wrong. In fact, when you have a lot of when the sample size becomes large, binomial distribution approaches normal distribution. So we actually use normal distribution to approximate binomial distribution. Okay. If you do not believe me, you go back to your what we did in this is lab session, the lab itself. Remember our 20 question, 50 question, it looks like a normal distribution curve. Okay. So question 2. Oops. Okay. Question 2. Okay, in a large population, 73% short-sighted. Okay, this is quite similar to Singapore. Okay, a sample of 7 people is chosen. What is the probability that all of them are short-sighted? So this becomes the probability of success is 0.73. Okay. So what you do is, so question 1 is A, all short-sighted, okay, which is the probability that x equals to 7 equals to 7, CR 7, 0.73 to the power of 7. Okay, 1 minus 0.73, which is 0.27 to the power of 0. Okay, so this gives you approximately 39.6% that all of you pick any 7 people by random, all of them are short-sighted. Okay, question B. You want to find more than 5. Now, more than 5 short-sighted. Is 5 included? More than 5. Is 5 included? Hello, anybody?
No.
No, okay. So then you find the probability of 6 plus the probability of 7. Okay, so you follow the same equation, you get I know, I got the wrong answer here. This is not 0.3, this is 0.110. Okay. So more than 5, 6 plus 7, you get 0.396. All right. Question C is, part C is a bit, you have 3 samples of 7. So in total, you have actually 21 persons. Okay. What is the probability that 10 persons out of 21 are short-sighted? Okay. So you're actually finding 10. But you only have 21 persons. It's not 7 persons anymore. So it's 21, 10. Okay. The probability remains the same, 0.73 of 10 and 0.2711. So you end up with about 0.00843. Okay, all of you got these three answers right? Okay, so this is how you work it out. Any problems so far?
No.
Okay. So question D. Question D is a bit more tricky. This question C, yeah. Question D, you are looking at a random number is selected. So you have n number persons, okay, to find to have 99% that one person is short-sighted. So basically you are almost like saying how many random people must you get so that there is 99% chance of finding one of these group of people that are short-sighted. So how do you do that? Okay. Essentially, the probability of more than 1 is 0.99. Okay, which in reverse, the probability of finding 0% that is short-sighted is actually less than 0.01 because it's 100% the opposite way. So how do you get this number? If you work it out, you end up with NC0 times 0.73, 0% short-sighted, okay, and you have 0.27 of n gives you less than or equal to 0.01. Okay, any number probability combination of 0 is always 1. So this is 1 times any number to the power of 0 is also 1. So you end up with just this 0.27. So you end up with here with 0.27 and okay. Then what you do is you take the ln or log, it doesn't matter. Okay. Okay. Then when you find out what is n is approximately 3.52. So you need minimum of 4 persons. So that is the answer. All right. Okay. Yes. Any problem?
Oh no, sorry.
Okay. Now then part E and part F. Okay. Part E asks you what is the probability of X that is more than okay. Let's repeat this again. So when the sample is large, you assume a normal distribution. Okay. That so X is normally distributed with n mean is 73 and the variance is 19.7. Okay, what is the probability of finding X that is more than 80? So you calculate out you will end up with that is more than 1.58. That gives you about 0.0571. Okay. If you want 70, now because you're actually looking at this here, right? This is 70 here. So you want 73. So you want 70, which is here, 70 to 80. So you want this area. So you need to multiply minus of this. So it's 1 minus probability that is more than 80. Okay. Minus of the probability that is less than 70. So you end up with about 0.0571 minus 0.2483. So you get about 0.6946. So this is for question 2. All right. Okay. Now question 3. Question 3. Anyone able to solve? Let's say we solve for part 1 first. Okay, question 3 says that there are 2 rounds of interview. Okay, the first round there are 10 interviewers, so the probability of passing the candidate is 0.9 for every interviewer. So let's look at it. Question 3. Okay, there are 10 interviewers, so n equals to 10. The probability that each interviewer passed is 0.9. Okay, but the candidate fails if one of them decides to fail him. So at most one of them decide to fail him. So you need at least 9 to pass him. Okay. So to go for a second round, qualify for round 2, essentially you need either at least 9 interviewers passing him, because you can only have 1 interviewer that doesn't allow him to go through, or 10. Okay. So that will give you about 0.736. So you have 73.6% chance of going for the second interview. Okay. Okay. Now, for the second round of interview, you have 3 candidates, but all of them need to pass. So you have second round interview, you have 3 candidates. Okay, but all of them need to pass. The passing rate for each interviewer is 0.8 lesser now. So to get, assuming they are over the first round, to pass round 2, you actually need all 3 of them to pass you. So then it is times 0.8 of 3, okay, 0.2 of 0, that gives you 0.512. That's assuming that you pass second interview. Now, in order to get the probability of getting the job, is you have to pass the first interview, then you pass the second interview, which means that the probability of qualifying for round 2 times the probability of passing round 2. So you just multiply both up. 0.736 times 0.512, you get about 0.377. Okay. After that, it asks you what is the probability of what is the minimum number that you need to interview in order to have minimum number of interview that you have 98% chance of one or more candidate. So it's back to the same question again. Okay. So the third step, which is you have the probability is actually 0.7377. Okay. But you need, what's the minimum number? Okay, that is more than or equals to 1, so that you have more than 98% of finding a successful interview, successful person. Okay. So which means that if it is less than or equals to, just put equals to, equals to 0, it is actually less than 0.02. Okay. Then in order to calculate this, you have n 0, 0.377 to the power of 0 times 1 minus 0.377 to the power of n. This gives you equals to or less than 0.02. So in short, you have 0.623 to the power of n, gives you less than 0.02% of chance. So you work it out, and will be approximately 8.26 or 8.267. So you need to interview minimum of 9 persons. Okay. You need minimum to interview 9 persons so that you have 98% chance that at least one person is able to pass through both interviews. All right. Any problems so far with this? Hello, any problem? Or silent?
No problem.
Okay, good. Oh, whose baby is that? All right, question 4. So Gordon Ramsay has a cake company. Okay. So now you have a box of cakes. So they are in box of 6. So n is 6 cakes. Okay. The probability that each cake is a fruit cake is 40%. So you want to find out what is the probability that contains exactly 2 fruit cake. So this is easy. Probability of 2 fruit cake will be 6, 2, and here will be 0.4 to the power of 2 times 0.6 to the power of 4. This gives you about 0.311. Okay. So you have 31.1% chance that the box has exactly 2 fruit cake. B, at least 5 fruit cake. Okay. So you need 5 and 6. So at least 5 fruit cake means there are either 5 or 6 fruit cake. Okay, so you work it out. Similarly, you get 0.04096, about 4.1% chance. Okay. Now this is, so you have it means 0.04096, that chance that at least 5 fruit cakes out of 6. Okay. Question C is different. Question C, part C tells you that you want to buy a box. You randomly sell, you want to buy, so you Sehun bought 10 boxes. Okay. So you want to find what is the probability that at least one box with 5 fruitcakes. Now, so n equals to 10, because here n equals to 10. Okay. But the probability of success is actually from question C is 0.04096, because this is the probability of, let me use another color. This is the probability of at least 5 fruitcake. Okay, so it's at least 5 fruitcake, which is here. And you want to have at least one box. So at least one box means that if you let y be the number of boxes, at least one is actually 1 minus the probability of 0 boxes. So you just take 1 minus 10, 0, 0.04096 of 0 multiplied by 1 minus 0.04096 to the power of 10. So you end up with about 0.342. Okay, so you have 34.2% chance that at least one box in the 10 boxes bought containing at least 5 fruitcakes. Okay, any problem with this question? Let me include any problem here. 1, 2. Yes, what?
P, the probability of getting the fruitcakes, the box, however, y is greater than 1, right? Then
Yes.
equals to 1 minus probability of not. I don't get that part. Can you explain
You mean
again?
this part here?
Yeah, that part.
Okay, so the probability of getting the box with so the probability that at least one box with 5 fruitcake, you can do 5 fruit, can do at least one box, right? So you can do one box, 2 box, 3 box, 4 box, 5 box, under 10 boxes, which you're going to kill yourself. Or you're going to say that what is the probability that no box, that means absolutely all the boxes have no 5 fruitcake. So you do the opposite. What I'm trying to do.
Because the question say at least one, is it?
At least one box, correct?
If the question say one box with 5 fruitcakes,
if you say one box with 5 fruitcake, then okay, so let me just use a different color pen. If the question say that what is the probability that one box has 5 fruitcakes? Is that a question?
Yes.
Okay, then you just take this probability equals to 1, then will be 10, 1, and here will be 0.04096 to the power of 1 minus 1 minus 0.4096 to the power of 9. Hello?
Okay, understood.
Yeah.
Thank you.
Okay. All right. So mainly is reading the question carefully. I keep stressing reading a question carefully. This type of probability question, students tend to get it wrong because you never read the question properly. You know how to do it. No problem with that. You know how to do it. Okay. Okay. So question number 5. Okay, question number 5 says that Paul's weekly spending, okay, is Paul's weekly spending average of $30, standard deviation of $10. Okay. So question part A, what is the probability that he will spend more than $40? Okay. So let's say the spending more than $40. So how do you do that? You have to convert it to the z-score. Okay. So here you are actually doing something like this. Okay. So this is the spending. Average is 30. Okay. One standard deviation is 40. And then what you're trying to figure out is what is this area. So it's more than 40 minus mean, which is 30, divide by 10. So you end up with P Z is more than 1. So you go to the table. 1 is here. 15.87%. So it is 15.87%. The area here is 15.87%. All right. So question B asks you what is the probability that he will spend less than $25. So same thing, if you draw it out, this is 30, here is 20. So the probability of spending less than $25, you want to find this area. Okay. Okay. So now convert it to your Z. So less than $25 is 25 minus 30 divided by 10. Then you find that this is less than minus 0.5. Okay, so in the z-axis, so this is a spending axis. So this is 0, this is minus 1. So here is 0.5 minus 0.5. Since you cannot take 0.5, you can only take minus 0.5, you can take 0.5. So basically, this is the area, the opposite side. So it's equivalent to more than 0.5. Okay, then you go back to our table, 0.5, 0.3085. you have 0.3085. Okay, about 30.9%, 30.85%. Question C is then similar. What is the least amount that he need to set aside so that he's 99% sure that you're going to have enough money? Okay, so same thing. What is the spending that he needs to set that will give you 0.99? Okay, so let's work this out. If we do that, we also say that you want to have a z-axis. Okay, you want to set 99% chance, which means that the area that you shade is 0.99. So indirectly, what is the area of here? This is 0.01. All right. So how much money you need to set so that you are on the opposite side? It's 1%. Okay. So here you end up with the spending minus of $30 divided by $10 is 0.99. So you reverse it back. The amount of dollars minus 30 over 10 is actually the blue one, 0.01. So this is a blue region. So then you find out what is this number to give you here, 0.01. So in order for you to get 10, so you go to the table and look for 0.01. So 0.01 is here. This is the next number. So it's 0.230, 0.231, 0.232, 0.233. Okay. Because you take 0.232, you are going to have lesser than 99%. Okay. So this gives you 2.33. Okay. Then you work out, you end up with he needs to set aside $53.3 so that he has 99% chance of sure that, so this is here is $53.3 when the average here is $30. So that's the answer. Any question? Hello, all silent? Alive? Okay, if not, should be okay, right? It's just keep, you have to draw
No
and...
questions, no questions.
Okay, so the last one. The last one is actually the same again. You know, we just keep setting the same question all over time. Okay, so question 6 says that the mean lifetime is actually 18.7 months. Okay, the standard deviation is 2.05 months. That's a warranty. Okay, so what is the probability? What am I doing? What is the probability that a tracker have a lifetime of more than 20 months? Convert it into a Z value. Okay, so here, if you want to draw it out, it will look something like this. Okay, so here is 20 months. No, okay. This is 18.7 months. Somewhere here is 20 months. So you want to find this area. Okay. So it's more than 20 minus 18.7 divided by 2.05. You end up with Z that is more than, can somebody give me an answer? What is 20 minus 18.7 divided by 2.05?
Zero 0.634.
0.634, okay. So let's look 0.63, 1, 2, 3. So it's about here. This number is 0.60, 61, 62, 63, around this, but have a lifetime, okay? So you can take either one of the two answers and I'm quite fine with it. So it is approximately 0.2643. Now, if you use Excel to calculate, then it will give you more significant figures. So B, the probability that is between 15.1 to 19.9. Then this is where you have. This is 18.7. So you have this 15.1 to 19.9. So what you want is actually this area here. Okay. So again, what you do is you take 1 minus the other two areas. Right? Okay. So you know that already. So you take 1 minus P, that is more than 19.9 minus P, that is less than 15.1. So you can't just put it into an equation. In fact, it is the same equation that you use here. It's always the same equation. Okay. So you get 1 minus 0.0392 minus 0.2776. You end up with 0.6832. Okay, so this is 0.6832 and more than 19.9. More than 19.9. So more than 19.9, this you have 0.2776 here. This is the 0.0392. Okay. So question C. How many months of warranty so that you do not want to exchange more than 10%? Same thing. The number that you do not want to exchange more than 10%. Okay. So you convert back into the Z value and minus 18.7 divided by 2.05, 0.1. Okay. So what you end up with is to get 0.1. Let's go back to our table. To get 0.1, 0.1, 0.1, 0.1, 0.1, 0.1, 128, 0.1, 1.28. Okay, you can actually use about 1.29. Okay, less than 1.29 here. Okay, so essentially, n minus 18.7 over 2.05 is actually less than minus 1.29. Then you calculate. So the warranty should be about 16 months or less. So you get 16 points, n equals to 16 point something. Okay. All right, so that's it. Any questions? Can somebody help me calculate what is n here? Minus 1.29 times 2.05 minus 18.7. Can somebody help me calculate what is this number?
Negative 21.3.
21.3. Okay, so here by right you should have yeah, so it's you need to have about 21 months or less. Okay, so if you take the answer key is actually here is 1.28. So if it's 1.28, then you get 16 months. All right. Okay. All right. Yeah, so that's all that we have for today. So make sure you get your normal distribution correctly. That's very important. Okay.
Oh dear, sorry. I put minus 18.7 instead of plus 18.7. The answer is actually 16.0.
16.0. Okay, so
I think. Yeah. Hold on. Sorry.
so this is 16.0. Okay, so you end up with 16. All right. Okay, so yeah, you end up with 16.0. Okay.
Why
What?
is 1.29 negative?
Oh, because you do the reverse. Because you see, n has to be something because you want to. If this is 18.7 months. So 18.7 months, half of the watch will die, half of the tracker will die. Correct? So you want to only exchange for 10% of the tracker. So what is a warranty period has to be lesser than 18 ma? Right? So this is the 0.1 here.
Oh, so you calculating the left side of the curve.
Correct.
So
correct.
that's why it's negative lah.
Yes.
Oh,
Yep.
okay.
Yeah. Because there can be a chance that when you buy the tracker, it dies already on the first day. Then it will be the opposite end ma. Then you slowly die until there will be one time that almost everything dies on the other end, right? Because the lifespan is 18.7 months. So 18.7 months is half of them should die. So if your warranty period is 18 months, then you're going to pay for half of the warranty more, no?
Oh, okay.
Yeah.
Then why you use 2.9 instead of 2.8 lah? Cause 2.8 is closer to 0.1 what, no meh?
Actually, let me see. Why should I use 2.8 2.9? Actually, I should use 2.8, correct? Because 2.8, yeah, 2.8 I should use 2.8, correct? Rather than 2.9. It's closer to 1, as you say. And
Okay.
yours 2.9, you actually have more than it's more than 10%, slightly more than 10%. So yeah, correct. This should be 2.8. 2.8. Yeah, so this is 2.8. So you end up with 16 point, what is MI? 16.076 or so. Yeah. I mean, that's how some of the warranty is calculated. You realize that some electrical appliances, some laptops and all this dies kind of 2 months after the warranty dies. Yeah. But it's not exactly normally distributed, but yeah, you get there.
Okay, thank you.
Bye. Okay, so that's all for today. Okay, and what I'm doing here, how do I erase this? Okay. Okay, yep, so let me just flip over. So in short, that's all that we have for this tutorial. Yep, bye-bye.
Thank you. Bye bye.
Bye.